Welcome everybody. Let's give a couple of minutes from the start to everyone join our webinar, and we will start in a moment.
Yes. People can see me and hear me now. And welcome to our mining webinar, one of our favorite subjects, something close to our hearts, being from the north of Sweden in Kiruna. It's going to be me and Darius with you here today. And yes, here is our agenda. So we're going to introduce ourselves, our work, and a little bit of use cases for what we can actually do for you and your mining solutions. And here we are. We were born in 2019, so haven't been around so long, but we've made quite an impact, I would say, so far in the mining industry. We've actually won a mining innovation award, as you can see here, among other ones. But to tell you a little bit more about Lidar, in case you're not quite sure, it's a technology solution that allows you to have a super accurate, super precise idea of the physical environment. And we do that by firing lasers and measuring the time it takes for that laser to get back. Something you couldn't really do with a measuring stick, eyes, or your camera. And you can imagine the benefits that that has for a place like a mine. Very good for avoiding unnecessary hiccups in the workplace, as you could say. And the data we give back to you is a very precise 3D map that comes in varying resolutions, which our resident expert Darius will get into a little bit later on. And as you can see here, we're represented in 11 countries, which is almost the same number as the amount of developers we have. So it lets us be a little bit more agile and flexible. And our team here comes from a range of different backgrounds and expertise. So yeah, we're very happy to have you here so we can get stuck into the nitty and the gritty. So I think our friend Darius is going to be very eager to jump in and give you the details there. So I'll pass it on over to him one side. Figure that out. I said, hey, there you go. Yeah, take it away, Darius.
Thank you very much, Jordan, and welcome everybody. Let's jump in the Lidar technology. When we are talking about Lidar technology, it is, I would say, already quite a mature technology with multiple sensor manufacturers. And if you are wondering what the Lidar is a, in a nutshell, a device which sends the laser pulses, measures the reflection, and counting the time from the reflection, as you can see on the animation on the bottom right corner of this slide. Sorry. And in the lidars, you might find a lot of different models, a lot of different variations. You can get real-time data up to 240 Hertz. It can be robust for harsh environments. Range from very short range up to 350 meters, and some of the specialized lidars can cover even longer ranges. It does not matter the light conditions for this sensor, because this is an active sensor. It emits its own light and measures the reflection of its own light, so it doesn't really matter if this is day or night. It creates millions of measurement points every second, and you can find various fields of use, like from the 360 lidars, which are spinning around and measure data in all directions, to directional lidars, so you can think about it as a cameras. And then same as in the camera world, you might have wide or narrow field of view as well. There is couple of different types of the lidars. The most simple one is something what we call a single beam lidar. It is one measurement point, and as you can see in the picture above, you can find it in hardware store, this kind of distance measurement device. And this device is equipped, or the lidar inside this device is equipped with a transmitter and receiver. Each has own lenses, and then it measures the time of flight for the slide. When we go further with the development, with the technology, there is something we call 2D lidars, and this is typically like plane measurements. They are quite popular for making 2D maps, for making simple 2D obstacle avoidance, and you can find it already quite a lot in the industry, in for example, safety for, let's say, forklifts and so on, where you might need this kind of just two-dimensional information, or in your household in robotic vacuum cleaners, 2D lidars, which are doing the map of your apartment, and the robot knows where it is, where it's supposed to clean, where it already cleaned. And from the technology perspective, it is similar as single beam lidar. You just add rotation and measurement of the angle where the measurement is taken, the distance measurement is taken. Then combining all those measurements together, you might get, you will get this plane measurements. The next step for the 3D for the lidar technology is 3D lidars, and 3D lidars, you can think about them similarly as 2D lidars, just they have multiple transmitters and receivers with different angles and measurement, making measurement same time. And based on that, you are getting this three-dimensional information simultaneously from all the lidars or lasers inside of this hardware. You might find different kinds of 3D lidars on the market, from simple ones which are providing 0.6 up to more advanced or quite advanced, which are providing 5.2 million points per second, various ranges and precision down to the centimeter level. So quite a lot of possibilities to choose from. And the next one in this evolution of the lidars is something we call 4D lidar. And fourth dimension, basically it is very similar as a 3D lidar. It measures three-dimensional space, but fourth dimension in this particular case is instant velocity. As before we had position of the point in XYZ dimensions, in the 4D lidar you are getting also velocity per point. And this is a lidar which is mainly developed for automotive industry, but a lot of industries might take advantage of this extra information. And this technology, in particular lidars which I'm mentioning now, is called frequency modulated continuous wave lidars, and it differs from before in a way that the lidar sends different modulated light pulses, and it has very powerful analyzing electronics on board, which are checking which pulse has been sent in which time and which pulse has been received in which time. So it can match those two pulses and match the time, and based on that also get the velocity by the Doppler effect. Comparison between LiDAR and other technologies. Those are the most typical technologies we are comparing with, which is radar and the video cameras, where the LiDAR will give you outstanding point precision, where compared to the radar and video, you are lacking this information, such a precision as LiDAR can provide. Also, LiDAR managing bad visibility and weather conditions in a very good way. I would say similarly to the radar, but much better than video. Integrity, which is very important in many workplaces. LiDAR will ensure that you don't have problems with like GDPR, because as you can recognize that the object moving around is a human, but you cannot recognize who is this particular person with just the LiDAR data. So it helps with keeping integrity of the workplaces in a very high level. And also it is immune for metal and reflections. So as you can think about industrial places, they are full of metal structures. And in those kind of situations, radar sensors struggle a lot and have big problems to measure anything at all, where the LiDAR is not having any problem like that. So you can think about a LiDAR technology as one which can contribute by a lot and can basically get all the advantages from the radar and the video and cover disadvantages of those two technologies as well. In general, FlashEye software can offer you a lot of features, and I will mention several use cases now, but keep in mind that those use cases are just a teaser for you and something which can trigger your thinking about how this LiDAR, how this technology can be applied in your problems, how it can help you to solve your problems and be beneficial from both safety and efficiency perspectives. In general, FlashEye's software toolbox, as we call it, is easy to set up. We have multiple features like classification of the objects, like measurements, statistics, and so on. We can create three-dimensional zones, so it is very easy to create those zones, modify them, make zones in the zones, and more. And also integrations with already existing systems. And about integrations, I will mention a little bit more later on. And jumping more into the use cases. First, changing the way of the working. As you can see in the traditional workplace, in a traditional factory, you have multiple different units. You have conveyor belts, you have stockpiles, you have all this logistics with managing the vehicles, keeping people safe, and have production most efficient. And in current situation, still a lot of those things are done or secured by people sitting in the control rooms, looking the camera streams, checking the control values, and it is very human dependent, where the goal is to digitalize and automate operations to make them safer first and also more efficient. And this can be done only when you have trustworthy and reliable data. And as we know, usually just a sensor, single sensor, first, it might be difficult to integrate. Second, it might not provide this trustworthy data right out of the box. And then you need some software which will process this data and actually ensure that everything which is taken to the consideration, which is sent further to the automation software, is correct. And this is how we are doing the understand of the surroundings in real time with state-of-the-art 3D sensors. It all starts with high accuracy, high precision sensor, which have a lot of points, and we can use those points to filter and to create proper events, proper information, proper data. We apply on top of those 3D sensors, on top of the raw data stream, our FlashEye software, which is a real-time, which is easy to set up, as I mentioned before, all those great features. And then we're connecting this to already existing systems that automate the operations. They can do analysis, they can present the results, react, control, and measure. And this is something which already existing in the market. If not, if there is some need of some very special analysis of the 3D data, then of course FlashEye have you covered and help in those kind of situations as well. And with all of this, all these toolboxes, we can say, your goals will be reached. You will be able to automate operations. You will be able to improve safety and quality, and also you will reach your sustainability goals. And now moving to the use cases, something which, as I said, this is a couple of typical use cases we are usually talking, or we have customers using our systems for that purposes, but take it as just indication what can be done, and as just food for your thoughts, what actually your projects can look like or alike. So the first use case in those kind of industrial mining situation is about volume measurements, and we talk about either continuous volume measurements or once every 5 minutes, once every day. And with the Lidar system, you install the system once and you get the information about volume on your stockpiles whenever you need and how often you need. And based on the Lidar, the accuracy of those measurements is really high because the sensors have outstanding precision. And it can be applied for indoor and outdoor scenarios. There is no limit in that perspective. And also there is no limit of what kind of stock material you want to measure the volume of. It can be a gravel, it can be wood chips, it can be pellets and so on. So it is very material independent. But the thing what you have to have in your mind is that this is line of sight sensors and will measure the volumes of the things which are in line of sight. So something to consider when you are setting up such a system. And also it does not penetrate the materials, because this is one thing which we are quite often getting this question, if we can check, for example, density or moisture content. It is only the system is meant to measure the volume, so line of sight measurements of the shape and then calculate the volume. Next typical use case what we are covering is conveyor belt monitoring and safety. And in this data on the right side, you see in the middle conveyor belt, which is red stream underneath. The blue box is a sensor actually, and then you have barriers on the left and right side. So with this single installation, you can ensure the safety around the conveyor belt, because you can create safety zones which will trigger alarms when someone will reach closer or actually will try to reach over the barriers and put their hands into the conveyor belt. You can get immediate stop in such a situation. But on the conveyor belt part, we can measure information like material deviations. So what is the standard size of the material on the conveyor belt? And if this standard size is changing, then bring the warning, for example, because in some places it might mean that the material, when material changes its size, some parts of the process might get damaged or degrade its quality, and then some reaction is necessary. And this information might help you to have this predictive maintenance of in a bigger scope of your production facility, and help to keep you up and running and schedule this maintenance and so on. Another information which such a system can provide you is the top size, where we measure the biggest object on the conveyor belt. And also, again, this information might be very useful, not only as it is, but for connection with other informations in the process. Also, we can measure volumetric flow, so how much volume is moving on the conveyor belt. And then this is for the logistics, for all this optimization processes and so on. And as I mentioned in the beginning, human proximity detection, to be sure that everyone is safe around this structure, and if someone is making some not responsible movements, to ensure that process can stop immediately. Another use case is a process optimization, and in this use case, it can cover so much. Basically, you can think about it, about the sensor that gives you three-dimensional information of the items around or in the processing plant, and you know exactly with precision with like centimeter precision, you know where the objects are in this area. And based on this information, you can optimize, you can time your process much better. and you can ensure that there is still keeping safety and high speed of the flow in your process. This will vary from the process to the process, but thing which you have to have in mind is that you are getting real-time data, you are getting basically actionable data if something is in the area or not. And based on that, you can design your process in a different way, in much more natural way than currently using a lot of like single laser beams and a lot of digital inputs outputs for traditional PLC. One of specialized use cases what we had is a rock breaker, as we call it. So it is a device which is meant to crush the rocks on this kind of grid, as you can see on the upper image. And nowadays it is done either by human on the spot or with tele-operated machines. With Lidar system, as you can see on the left side, we can detect those rocks very easily, and we know exactly position of those rocks. We can send this position to external systems like the rock breaker, and then the automation of this rock breaker device will take care of the aiming the head of this rock breaker and proceed with its with breaking of the rock so it can fall through the grid. And as I said, still high accuracy, and also in the same situation you will ensure that no human is around, because we clearly distinguish between rock, human, robotic arm, and so on. So you will, by using Lidar system, you will ensure this safety as well. Moving on with the use cases, the next one we have is smart mine entrances. And this can cover a lot, but in general, what we are doing with the Lidar system, we are collecting data while the objects, vehicles are moving around, and building 3D models of those objects. So you exactly know what kind of vehicle entered the mine, what kind of vehicle moved out from the mine, and this information can be used, for example, for ventilation on demand, because you know exactly what is happening, where things are happening in the mine, and so on. Having this three-dimensional information about vehicles, especially of the trucks, you might right away get information about material tracking, because we can build these models of trucks which are filled, trucks which are empty, and extract the volume information, how much material has been moved out from the mine. And that can be used for statistics, that can be used for many different things in the management and in the logistics. Also, something like tag verification, because nowadays in most of the mines, every vehicle have some RFID tag so it is verified that it's entering as well to the mine. But sometimes those tags are damaged and not functional. So if a LiDAR system see vehicle which is moving along the tunnel or entering the mine, but it is not verified by the tag, it can raise the alarm that something is going wrong and check what is happening. And also, as I mentioned before, statistics, something which everyone in the management will like, measure the performance, keep the performance high, and be sure that it is as high as possible, keeping the safety regulations. So many parameters which again can lead to optimization of this kind of mining process, overall mining process. And another use case, something which I mentioned in other use cases as well, but something which is, I would say, one of the most important one, which is machine safety, basically safety of the personnel. Here you can see a person entering the zone, which is stop machine zone, and the zone become red, means basically, as the name of the zone say, stop the machine. And this can be done in a way to ensure that only when person is coming into this zone, the machine is stopped, or whenever some other object will come to the zone, stop the machine. And in our software, you can create multiple zones. You can create basically from super small zone to super big zone. Basically there is no limitation in the size of the zone. There is no limitation of the number of zones. The one thing which you have to consider while setting such a system up is about how much the sensor will see, if the field of view will be enough, if the resolution will be high enough to detect what you want. But again, if you have some considerations about those questions, we are testing, we are developing, we are integrating multiple sensors, and we can help you with setting up, with selecting the best sensor for your application. And talking about sensors, this is something which I would say bring us in a very unique position, because our software supports multiple brands of the sensors, 3D, 2D sensors, and some of those you might already use in some of the areas of your process. Some of those sensors might be completely new for you, but the great thing with FlashEye system is that you might integrate multiple sensors in one system, and those sensors can be from multiple different brands. So you might have area with high resolution and low frequency sensor, together with area where you have high speed sensor with lower resolution. Combining all those things together into FlashEye system, putting analysis of what we are having in our system, then streaming this data, for example, volumetric flow or volume data, out over, let's say, OPC UA or MQTT to your already existing automation systems, or connecting it with slightly older systems with already existing, like older PLCs, through standard digital inputs and outputs. And all this together makes your mining solution, again, more efficient and safer for everyone around. All right, let's see. We have if we have some questions regarding what we just presented. All right. There is, as I see, there we didn't receive any questions, but I will just summarize you very quickly what you have to consider when you are going with the Lidar solution. First, it is high. You can choose from high to low resolution sensors. You can choose from high speed to lower speed sensors, with multiple different field of views, with 360 degrees around field of view, with narrow or wide field of view. And with FlashEye software, you can integrate it in already existing systems. So it is easy to go and quick to go with basically moving your automation, moving your safety, moving your production to another level. And do we have Jordan with us? Would you like to wrap it up, or should I do that.
I wouldn't mind wrapping it up. I'd like to wrap it up.
Thank you.
Thank you very much. So I guess the key takeaways we can have from that is that we can start with Lidar today. As Darius mentioned, there's so many integrations that our software provides. So you don't have to jump through so many hoops to integrate a flashlight solution into yours. Lidar's a lot more accessible these days than it was also. It's not this kind of obscure, mysterious technology that's kind of over there with the niche research projects and things. You can get started with it as soon as today. And as you saw through the use cases that Darius provided, the problems that we're able to solve now just weren't doable before, and this technology allows us to really get that kind of intimate knowledge of the goings on of our physical world. So I think it's good if you start with the Lidar today. And also, going back to the first point, it's a complement to your traditional solutions. We're not trying to kind of monopolize the world. We really just want to make things easier for everybody, so you can integrate it with your PTZ camera solutions. You can integrate it with any kind of sensor that you have already. Our aim with everything that we've heard today is to make the world a safer place, optimize and digitize solutions as much as possible so that the human work doesn't become obsolete. It actually allows you to focus on the more probably critical operations in the mining or other industries. So if you want to know more, then please let us know. This is our email here at info@flashlight.se. Follow us on LinkedIn also. That's where we're mostly active with the updates of our development or any kind of trade shows. We're going to be at future webinars, which we will be having within a month or so. And our blog posts will be coming up there also. So yes, thank you very much for joining us today. I hope it was informative and you're now very excited about Lidar and potentially what Flashlight can do for you and your operations. Thank you and have a great day.